Good morning. Now I have come with a new topic, that is acid base balance, and it will be dealt in few parts. This is the first part, that is the basics of acid base balance. Now, first of all, acid and bases. We should understand what are acids and what are bases. So, acid, it is any compound which forms H plus ion in the solution. So acid is any compound that forms a H plus ion in the solution. And next is the base. So base, is any compound which combines with H plus ion in the solution. So one example of base is bicarbonate. This bicarbonate will accept H plus ions to form carbonic acid. And with these acids and bases, the normal pH of blood is 7.35 to 7.45. Now, there are two terms called acidosis and alkalosis. Acidosis is the physiological state resulting from abnormally low plasma pH. So, if the plasma pH is abnormally low, that is called acidosis. And alkalosis is a physiological state resulting from abnormally high plasma pH. So there is definition for acidemia and alkalemia. If the plasma pH is less than 7.35, it's called acidemia. And if the plasma pH is more than 7.45, it is called alkalemia. Now, the basic of acid-base balance is by Henderson-Hasselbalch equation. In this calculation, pH, the formula for pH is pKa plus log of HCO3 by 0.03 into PCO2. Substituting this pKa, that constant, it is 6.1 plus log HCO3 by 0.03 into PCO2. So it finally shows that pH is a function of the ratio between bicarbonate and PCO2. Now, PCO2. The normal levels of PCO2 is 35 to 45. As ventilatory parameter, they'll take it as 40 plus or minus 4. And normal levels of HCO3 is 22 to 26 millimole per liter. Now, there are other volatile acids. These volatile acids are produced by the oxidative metabolism of carbohydrate, fat, protein. Normally, 15,000 to 20,000 millimoles of CO2 is produced per day. And this excess CO2 is excreted through lungs as carbon dioxide. Now, there are some entity called fixed acids. Fixed acids are those acids that do not leave the body unless it is eliminated by the kidney. So it remains in the body fluid until the elimination by kidney. It includes sulfuric acid, phosphoric acid, organic acid, and these are the important fixed acids in the body. These are produced by the catabolism of amino acids. Now let's come to an important topic called buffering. So if there is any alteration in pH, that is acidemia or alkalemia, the buffer comes into action. So these buffers are the first line of defense for this change in pH. Normally, up to 50 to 100 milliequivalent per day changes are produced. So there are bicarbonate buffers and non-bicarbonate buffers. Non-bicarbonate buffer include hemoglobin buffer, protein buffer, and phosphate buffer. The blood buffer system acts instantaneously and regulate pH by binding or releasing H+. Now, carbonic acid bicarbonate buffer system is the first buffer we are speaking. So, the CO2 will combine with H2O to form H2CO3. This H2CO3 will produce H plus and HCO3 minus. So this carbon dioxide in the body, most cell it is generated most body cell will generate carbon dioxide, and it is converted into carbonic acid, which dissociate into H plus and bicarbonate. So this carbonic acid bicarbonate buffer system prevents change in pH caused by the organic acid and fixed acids. But the thing about this is it cannot protect ECM from changes in pH from elevated or depressed level of CO2, and it function when the function when the RS system and respiratory system is under control and it's working normally. That time only this carbonate bicarbonate buffer will be able to work, and the ability of this buffer is limited by HCO3 availability. If there is no HCO3 available, means this buffer won't be able to work. Now, next one is hemoglobin buffer system. Hemoglobin means this is the red cell, RBC. So the CO2 in the blood will diffuse into the hemoglobin without requiring any transporter, and the CO2 will combine with H2O to form H2CO3, which dissociate into H plus and HCO3 minus. And this HCO3 minus it will move out of the cell, and this bicarb move out of the cell to the plasma, and that time chloride will be shifted back to the cell. This is called chloride shift. Now this exchange of HCO3 and chloride is called chloride shift. Now hydrogen ions which are present or present after the dissociation of H2CO3, it will combine with hemoglobin to form HHP. So these hydrogen ions are buffered by the hemoglobin molecules, and it is the only intracellular buffer system with an immediate effect on ECF pH. Okay, and it helps to prevent major changes in pH when plasma PCO2 is rising or falling. Now, the third one is phosphate buffer system. It consists of an anion that is H2PO4 minus. It's a weak acid, phosphatic acid, and it works like bicarbonate buffer system only, and it's important in buffering the pH of intracellular fluid. The limitation is it's a temporary solution to the limitation of buffer systems are it's only a temporary solution to the acid-base balance, and it do not eliminate H plus ions. And supply of buffer molecule, there is always a limitation. The next is respiratory regulation. Respiratory regulation happens means per day 10 to 12 millimoles of CO2 is accumulated, and it is transferred to lung as hemoglobin generated the HCO3 and hemoglobin bound. So H2CO3 produced will be dissociated into H plus and HCO3 minus. So there might be loss of CO2 or accumulation of CO2. There will be pH changes. So this is through the respiratory system. So, and the respiratory system will act by changes in PCO2 levels. So this balance is affected by neurorespiratory control of ventilation. So what happens in acidosis means acidosis is basically increase in PCO2 and decrease in HCO3 if it is respiratory. If it's metabolic, acidosis means decrease in HCO3, and there will be also decrease in PCO2. So in acidosis, what happens is there is a decrease in pH. So decrease in pH is now what happens is in acidosis there will be trigger for ventilation. So there will be hyperventilation in acidosis. This hyperventilation will cause CO2 washout. Now alkalosis, what happens is the response is biphasic. Initially there will be an episode of hyperventilation which is followed by hypoventilation. So alkalosis, metabolic alkalosis means HCO3 is increased, BCO2. So initially there will be an hyperventilation followed by an hypoventilation. And another regulation is renal regulation. Renal regulation, here kidney is a defense against addition of volatile acids or alkali. It maintains the level of HCO3 minus, combining hydrogen ion with urinary buffer to form a titratable acids. So most of this, it is either through the secretion of HCO3 or absorption of HCO3. Most of the absorption happens in PCT, that is 70 to 90 percentage, loop of Henle 10 to 20 percentage, and DCT and calcium 4 to 7 percentage. The factors affecting the renal bicarbonate reabsorption is filtered rod of bicarbonate, there will be prolonged changes in PCO2 and extracellular fluid volume, and plasma chloride concentration, plasma potassium concentration, hormones, and glucocorticoids. These are the basics of acid base balance. And thank you.